Yeah, yeah.
Yeah,
But this is fine, right?
yes, that's
Yeah,
fine.
this is perfect.
Okay, cool.
Yeah.
Yeah, I'll stop sharing for now.
I love that loading screen.
Is audio coming through on the stream?
I don't know. I don't have it open. Should I?
Okay, no.
Yeah, it definitely is.
Okay. Oh, it is. Okay, great. Awesome. Okay, so Craig is saying that he can hear everything that we're saying.
Sweet.
Can confirm.
Is that a good thing?
Hi, everyone.
Okay, we might as
No
well
attention
just,
to the people behind the curtain.
Yeah.
I like that Alex is like occasionally getting like you're kind of like warping into another.
Oh yeah.
Hey everyone.
Hey, Mike.
Do it.
Hello! We're live!
Yay!
Hey.
Oh, should I start?
I think so, yeah. I think we should
Okay. Okay.
Hi, everyone.
We're all pros here. Hey, welcome everyone. We are doing a awesome, long overdue Angular Seattle and SeattleJS Teamup meetup online, as everything is these days. We're really glad you all could make it. And we have some very special guests today, so we're really excited about this meetup. But first we have to kind of go over some of the usual news and tidbits. So let's run through those. If you haven't heard of Angular Seattle, welcome. We are Angular developers in Seattle. Our purpose is like really to develop new speakers, like help people, you know, just find friends and contacts in the community and to run sustainably. We like to have like a lot of different types of events, and we're always looking for ideas. And we have like a number of organizers. These are some of our fantastic organizers who make everything happen. And we're always looking for new people to come and join our awesome crew. We actually have like a ton of fun, totally honestly. So if you're interested in that, like, I don't know, put it in the chat or like find us on Slack. And you should come talk to us. We're pretty friendly. Yeah, so I just said, this is this is the same slide. We're cool people. Come hang out with us. This is the same thing said pretty much a different way. We're always looking for like new ideas, you know, like new things to do. So if you have any ideas or want to team up in any way, let's do that. Or if you want to give a talk, this is a great place to like practice speaking. I got really comfortable with speaking in Angular Seattle. I'd like given some talks before I started, but like really it's like a fantastic way to just get comfortable in front of like a group of really friendly people. And like you can get your talks recorded or not if you're not comfortable with that. So yeah, come talk to us if you're interested in that. So like everybody right now, we're doing everything online. And we are trying to come up with new formats. We actually have a pretty special one today. We're setting up like a Rambly instance, I guess. If you haven't heard of Rambly, it's like a cool environment where you can like pretty much like you pick an avatar and then you like hang out in a chat room that's kind of like a game. And the cool thing about it is like your avatar moves and like the voice of like all the people around you will like change, or like the volume will change. So it's kind of like being in a real environment where you can like go talk to people in a certain group and then like walk away from them if they're boring you, and then, you know, find somebody new to hang out with. So you should try it out with us. It's going to be really fun. Brendan.
All right. So, yeah, it is. So Rambly is going to be really fun. I'm looking forward to that. Hi, I'm Brendan. I'm one of the organizers both for Angular Seattle and for SeattleJS. And first I wanted to say we've been wanting to do kind of a collaboration like this for a while, so I'm super excited that we can finally do this, and especially do it online so that you all can take part in it. So first off, this next August for SeattleJS marks 10 years of SeattleJS, 10 years of the JavaScript community in Seattle, and something that we're really excited about. We don't know exactly how we're going to be celebrating it. Usually we would have like our social around August-ish, but we're going to try and find some way to help make it special. So I just wanted to say thank you all for being part of 10 years of SeattleJS. In general, for SeattleJS, there's a ton of different ways to get involved, right? So you can, we're always looking for organizers and speakers, hosts and sponsors eventually, once we get back to doing this, you know, not online. So there's a ton of different ways to get involved. Yeah, organizers, speakers, hosts, and sponsors. And then if you do want to like propose a talk for SeattleJS, we have a super easy way to do it, you can find our GitHub. Here, Seattle, github.com/SeattleJS, and you just open up an issue on our GitHub, and you can choose which one you want, and there's a whole template there. It's super quick to fill out, and we have other ways you can stay engaged with the community. We have our Twitter at SeattleJS, and then we also have a Slack community too. So we have a pinned tweet on our Twitter where you can click to sign up and join our Slack workspace and hang out with everyone, and we do everything from online mentor chats to just hanging out and chatting about random JavaScript stuff. So yeah, we're looking forward to this event.
Nice. All right, so what we got on the agenda today, we have 2 talks, and I'm really excited that we have 2 guest speakers that are they would normally not be here in Seattle unless they came to visit us, which would be awesome. But they're both from different parts. So Zack DeRose is a senior engineer at Nrwl Technologies over in Arizona, and he is I'm happy to say that he's my coworker, colleague. He's fantastic. He's a reactive programming wizard. Whenever I have a question about reactive programming in general, I always go ask him. And he just started streaming on Twitch, which is really cool. So you should go check out his Twitch channel. And Alex Arushko. Oh, no problem, Zach. You're a really cool guy.
you're very kind.
And Alex Arushko is a software developer at Google, working on the Firebase console, a core NGRX team member, and he organizes a very successful Angular Toronto meetup. So also very cool, and we're very, very lucky to have him. And yeah, so if you stick around until the end, we're going to be hanging out on Rambly, like I mentioned before. So we'll be talking about the talks and just hanging out. So stick around if you're interested in that. And what happened here? Oh, did I just get to the end? I think I just got to the end. So let's move into the talks.
Sweet. Is it my turn here? Let me share my screen. And boom. Okay. There we go. Alrighty. So like Nicole had mentioned, I'm really into reactive programming, specifically RxJS. And I think part of the reason I'm into it is because I've long suspected that it's objectively better in a way I'm going to try to prove today. So we'll see. I may not prove it, and I may just fall on my face, and y'all can laugh at me, and that's fine. But I'm going to talk today a little bit about the differences between declarative and imperative. And then I'm going to present my hypothesis on why declarative is objectively better. So we'll see how it goes. We'll have fun. So I'll tell like a little bit of a narrative, break it up into parts. The first part maybe is most important, just talking about easy versus simple, a concept I think kind of transcends code. It's part of like human life. It's understanding that difference and mastering it, I think is really powerful. Then we'll talk about observables. So the RxJS library, what observables are, how they can be declarative, how they can also be imperative. And then we'll be looking at a couple examples in sections 3 and 4, a basic adding, and then like a kind of bizarre little app we'll look at that's just there to kind of inspect. And then I'm just going to deconstruct components, and then we'll get into my hypothesis. So we'll see how this goes. So first of all, for easy versus simple, on the left there, you see that's my 4-year-old. She's got her hair in a little French braid there, and that'll become important later. So, and a lot of this section is like completely taken from this talk I saw on YouTube called "Simple Made Easy" from Rich Hickey, who's the creator of Clojure. So easy and simple, I think they often, like if someone says easy or simple, you kind of just let them occupy the same space in your brain, like when you hear it. They mean about the same thing. But I think if we think about it closely, I think they actually mean something quite different. I think easy tends to refer to proximity, so how close at hand something is. Whereas in contrast, simple refers to like a lack of folds or dimensions, a lack of, you know, complecting, which is a word we'll get to in a little bit. And I think the difference between easy and simple really comes out when you think of their opposites. So the opposite of easy is difficult. By contrast, the opposite of simple is complex. So easy, simple, they sound about the same, but difficult and complex, I think those are two markedly different things. I think easy too is subjective. So easy for me is probably different than easy for you, easy for Alex. Difficult for me is probably different than it is for Alex. We're just different people, and we're in different places. So our proximity to certain things is different. Like it's just kind of how it goes. It's our view of things, I guess, that determine how easy something is. And it's also something relative. Like it's something that we as humans are like built to move around in. Like when we learn something new, like literally our brains develop new neural pathways. Like that's how this stuff works. So as we if we dedicate ourselves to learning something, we can take a concept that was difficult for us and move it to something that's easy. In contrast, simple, I think, is objective and fixed. If something has like a complexity of cardinality 4, for example, it's always going to have a complexity of cardinality 4. And as humans, we have really, really shitty RAM, by which I mean we can only like consider a few things at a time. We can only like keep them in readily available memory at a time. Once we start getting past 4, we have to start writing things down or like mapping things out, or putting something on paper, like kind of writing to disk to keep track of stuff. And there's not much we can do about that. Like it's very hard unless you're extremely talented or you know something I don't. It's hard to increase your like capacity to hold several folds or several dimensions in your brain at one time when you're considering a problem. And even though I'm contrasting these in this slide, simple and easy are not necessarily mutually exclusive. And I think like the ability from us to move from something that is difficult to easy, or something that is maybe simple and difficult, but then move ourselves to a point where that simple thing is now easy. I think that's the marriage to look to in our code, but also in our lives. And going back to Rich Hickey's talk, this image right here, I thought was just perfect. If you look at this is like the steps to braid something. I don't know what this braid is called, but we see figure 1. That's kind of like a code base in Greenfield that we just started, and like everything's easy, and you can just kind of go, like it's just everything works. But then as you move along, you get to figure 2, that's when you kind of push out this big feature. Figure 3 comes along, you're adding more things onto it. And before long, you end up in like this figure 6, which is just kind of like a nightmare to move around in. So like, if you can imagine making a change right here in this braid, like to do everything that entails, you have to kind of trace all these different strains back to their source. You got to understand everything that's going on underlying everything, and then you have to, when you're done with all that, you have to finagle this piece right here back so that it's back in the braid of stuff. And in this example, even there's this braid is very logical. Oftentimes with legacy code or code bases that even aren't that old, you tend to get like a rat's nest where there is no reason to it. Versus like making a change up here, that seems so much easier. The problem is we need to get into a place where by making a change, we're leaving it kind of in figure 1, as opposed to going to leaving things looking like figure 2. And maybe that means, you can see these are marked A, B, C, D. Maybe that means adding an E string or a fifth string or a sixth string rather than taking your existing strings and complecting them. And that's a word I'll probably be using here. So like the active going from figure 1 to figure 2, there's a word for that called complecting, where you're just taking something that's straightforward and twisting it a little bit. And there's sometimes you have to do that. Like sometimes business requirements dictate that. But yeah, it's not something we should do if we can all at all be able to. But it's something that we do all the time, like purposely, which is weird to think about. And the last thing I wanted to get on was sort of this graph of speed over time. When you're going for like the easiest thing at hand, I think like your speed starts out really high. You're able to do things really quick. But as time goes on, like you start progressing in that graph from figure 1 to figure 6, things just slow down. They slow down so hard. And by contrast, I think if you're able to leave things like in that figure 1 kind of straight lines, you're able to actually accelerate over time. And like in real life too, like for getting code, if we can move from this blue to the green in terms of like our overall like wellness, that's what we need to be going for. So I think there's something powerful. And this graph is completely anecdotal, but it absolutely resonated with me when I first saw this graph from the other presentation. So now that we've talked about sort of simple and easy, how they're a little bit different, I want that to be like present in our minds as we go on to the next parts of this narrative. So now we're going to talk a little bit about imperative versus declarative programming. So imperative programming it's kind of like this robot here. The robot has like a list of like a recipe almost that it follows. It goes through things one at a time and is just manipulating things as it goes. In contrast, declarative programming is kind of like having this system of pipes set up. And if you can think of it as we have like an object, a discrete object coming through the pipe. It's going to come through and like hydrate the different properties, the different dynamic properties that we need to change for our app. So just to address this, because I'm not sure how familiar everyone is with observables, but I think it's very easy for us to think of observables as just a promise replacement. And I think a lot of that is because I think a lot of our first exposures to observables is through like an HTTP request, which is very promise-like. But observables can be more than that. So I think observables are actually closer to a two-dimensional array, but not a two-dimensional array in the way you usually think of two-dimensional arrays, where it's like a nested array. I think arrays by themselves portray order and cardinality. There's like an order in which the objects of an array exist, and then there's a length to the array. Observables have that same order and cardinality, but it's all being played against the second dimension, like a temporal dimension of over time. We're seeing different things come through, different things being emitted. But like promises, they can also error incomplete. So that's where I think we also tend to think of them as promises. But I think they're closer to that temporal array than that. So I find the best mental model for thinking about observables is sort of these marble diagrams using ASCII art. In my opinion, that's the best way to do it. So if you can see my mouse, you can think of just progressing over time. The successful HTTP request at the very beginning, it's like we've made the request, we've sent out the request to the server, and then time is passing with each dash. And then at some point we receive an A, like an A object. It comes back, and then the observable completes, and then we're done. An erroring HTTP request, we make the request, time passes, and eventually we get an error back from the server, or an error back from the browser or something like that. But we can also think of it, those are both like kind of more promise. Like those two things seem very much like a promise. But we can also think of it as just a user clicking a button. This is a single observable, and like let's say this observable is starting when like a component loads, and then a little bit in the user clicks it, and then there's some time, and then they click again, and then they click it again, and then they click it again, and then there's a long pause, and then they click it again. Like so just think of observables that way, at least for purposes of this talk. One interesting thing about observables is that I think they're a particularly good fit for dynamic / reactive front end apps. Like, whoops, went too far. If we see this graph, like this, doing this imperatively, I think is just very difficult. And I think I've got enough time to share a little story about. I still remember this time in college. I was working on this group project. We were creating like a Star Trek game. I didn't know what I was doing. I was very early in my programming journey, and I'm working in Java Spring. I know very little about it. And I'm working with this teammate who's working on the back end. We've got it all figured out, where we got our data contracts figured out. And I'm finally able to show all the data he's sending me and be able to display, like at a single point in time, this is what it should look like. This is what everything should look like in Java Spring in my little native app here. And then I realize there's just this moment of horror that comes over me when I'm like, wait, I've got to send this user's move out to his server, and then I got to figure out how to change that. And there's so many things, different things that could be sent back, and there's so many different states I could have been in when I first sent that thing versus when I got it back. And I was just like, I don't even know what to do. And I solved it by just closing the window and opening it back up when the new thing came back in. And that's because I was looking at everything like just imperatively, just like this goes in here, this goes in here, this goes in here. But then when you have to like react to other things, it becomes very difficult. So we're going to look at a quick little example here. So this is a simple adding app. You'll see we have a +7 button and a +5 button, and up here we're just kind of keeping track of things. So we click 7 a couple times, click 5, click 7s, click 5s, and things just update. So let's look at this first from an imperative paradigm, and you can follow along on the link if you can see the stack blitz, and it'll have everything working. But we kind of set this essentially a global variable to keep track of our total. Excuse me. And then we define a function to add to that x, which is going to just make that x a little bit bigger depending on what gets passed in. And then it's going to get our element and update its text context. And then we're just going to, for our button, we're going to add a non-click listener to just add 7 to, use that add to x function and add 7. And for 5, same thing, we're just adding 5. But if you look at this, I think you can already see, if going back to that image of that braid and those strains, and things are starting to braid here already. Like add to x, it's kind of like, I don't know, it's kind of like these two things are sharing that variable, and things are starting to get twisted a little bit, and it's completely manageable. Like we can keep this all in our head for now. But we're starting to see like shades of some complexity start to creep in. And so the line count for this is 9. Compared to, this is using a declarative paradigm. Our line count is about twice as much, but still reasonable at 17. So alternatively, here we have a function that's going to create a click stream, I call it. So we're going to pass in the ID for an element and a corresponding number value, and we're going to get an observable of numbers. And that's just kind of like whenever the 5 gets clicked, we're going to have one observable for 5s, and whenever that 5 gets clicked, it's going to like emit a 5, and whenever the 7 separate observable for the 7, and we can see that here. The 7, whenever it gets clicked, it kind of just emits a 7. And then we're going to define our total in terms of merging the 5 stream and the 7 stream. And we're going to use the scan operator, which works exactly like reduce. And we're just going to take our accumulator, so pretty much the last thing that was emitted, and the latest thing we've seen from either our 5s or our 7s, and just add them up. And then at the end, all we're doing is just subscribing to that total. So whenever we see a change to the total, we go ahead and update our text context with that new value. And going back to the marble diagrams here, we can kind of see there was 2 7 clicks. So if you'll imagine like a long line kind of going through across things, we had a 7 and coming out of the 7 clicks, and then our total went to 7. And then we had another 7 and our total went to 14. And then if we let the video go a couple more, 5 got clicked twice. So we see 2 5s get emitted, and the total gets updated as well. And then a 7 gets clicked and a 5 gets clicked again. And so we're able to like, I think this is like very much in keeping. If you can get your mental model to think about it this way, I think now we're thinking about things in terms of like that figure 1 where everything is a very discrete, uncomplected, like straight strand. And I think that's so much easier to kind of keep in our minds when we go about things that way. So now we're going to look at a crazier example. You'd never do anything like this, but let's just look at it. So we're going to enter our name, and then we're going to generate a favorite color for ourselves. And then after some time, it's going to say, it's been a while since I decided or changed my name, so I'll probably change one of those soon. So it's like we're setting a name, we're generating a random color when you press the button. And then at some point of time after you've done one of those 2 things, we're going to add this onto our message for our app. But then when we click something different, you'll see that message goes away until 2 more seconds pass, and then we can see it again. So let's look at this imperatively. I know the text is really small here. The big thing to grasp, I think, is this line count. Like we're up to 61 right now. And we're kind of doing this thing where we're doing a closure, we're doing object-oriented programming. We have like a name property, a favorite color property, a time-elapsed property, a bunch of colors, and a method here that's going to update that output text depending on our state as defined by those properties. And like a method here to update the output, which is just grabbing that element and sticking the results of the other method in there. And then we're returning the object that exposes like the 2 public methods for updating a name and updating the favorite color. And then we're kind of attaching those to like event listeners on the buttons. So yeah, I think at this point we're getting significantly down that progression. Maybe this is a figure 3 or figure 4. Like it probably wouldn't be that hard to make a change in here, but we're definitely getting to the part where I'm like, well, what does this do again? Oh yeah, it calls this, which calls that, which calls that, and they're all kind of sharing this timer ID. You got to kind of remember how that timer ID gets set and all the different ways that could potentially change. So yeah, compared to that, there's a declarative paradigm. So this imperative was 61. When we're in the declarative, we're at 47. So we've gained a good amount. So here we have just an array of colors, array of our possible colors. We have a function to kind of like randomly generate one of those 4 colors. We have a pure function here based on a name, a favorite color, and time elapsed parameter. So 3 parameters to this pure function. This is going to give us a string. And then we're so that's kind of like some background. But then now we're getting to like the pipes we're laying down. So we have a name, this name observable that we're just going to get whenever our input field changes value. We're going to just see some new values coming through that. We're going to have a favorite color observable, which is just being defined by the clicks. Whenever we get a click event, we're going to call our pick new color function. It's going to give us a new color. And so we're just going to see over time that color is going to change. And then we have this 5-second timer, or I guess this is a 2-second timer here. That's a typo on my part. But this 2-second timer that we're going to like switch over to anytime we see one of these 2 things change. And our output here, so like our results, these are kind of the 3 things we define based on events we're getting. then we're defining this resulting output in terms of those three things, and just kind of using a combined latest here provided by RxJS. Whenever we see either of these two things emit, we're going to start a new timer, and if the timer has gone off, we're going to display one thing. If the timer hasn't, we're going to display the other. And so we see these things like, it's very much like before. I can still, like, even this is fairly complex, my mental model is pretty solid. Like, I have a name, I have a favorite color, I have a timer. So some combination of those three things, I'm just going to send it to my one function. I'm going to get my text. It doesn't really matter what any of these observables look like. I've already defined everything. I'm just going to let like events happen at this point. So we can kind of see that. I'm not going to go through this because I'll probably look a little crazy doing it all. But yeah, so that's kind of the deal. That's imperative versus declarative. And now just to think about components a little bit. What defines a component? So I think a component is really composed of three core things. You have like a set of states, which is a set of different modes a component could be in. Like if you're waiting for a response, you're in one mode. If you've already gotten the response back, you're in another. So that's like one example of state. There's a whole, like, state is like this black hole of complexity if you let it be. So that's one piece right there. Then there's our dynamic pieces. These are variables or properties that once changed, you'd expect like something in the UI to update. And then you have events and triggers, which are like user interactions or form updates or HTTP requests arrive or HTTP request errors. And this is where we get into the DeRose hypothesis. So my hypothesis is in imperative programming, we're going to find like a worst case code complexity. Think of it like you would like a worst case time complexity if you're thinking about this in terms of like an algorithm, how to define the time complexity of an algorithm. So in imperative programming, your worst case is equal to a certain n number of events. Like think of it like our input updating or a button getting clicked. There's some n number of those. And to determine complexity, we're going to take for each one of those events, there are another n number of dynamic properties that these handlers could affect. And then on top of that, there's another at least n, because like I said, like state can get into like this black hole of complexity. But there's at least n different number of states that you could be in that would affect how these handlers affect those dynamic properties. So again, thinking of this this arm, like this robot could have a whole bunch of different states. It could have, right now it has 4 rocks, but it could have any number of rocks. It could have any number of commands that we're telling it to do at any point in time. And so you like take all those things, like we're into this unmanageable heap of complexity. And then that's why I give this my verdict. The worst case complexity is at least like an n to the third. In contrast, we have declarative programming. And the worst case, I think, here is equal to n number of dynamic properties. So this was like, if we think of our last example, our name, our favorite color, the timer, there's some n number of those, and we've got to define each one of those. And to define each one of those, we have like n number of other dynamic properties we could kind of base that property off of, and also m number of events that could also affect it. So we're kind of clustering our events and our dynamic properties together, and that kind of flattened things out to an m plus m, which kind of gets like flattened down to just a single n. And then and that's kind of it, right? Like our state is already effectively defined in each one of our dynamic properties in the stream as we define it. And also in like the peer functions we map it through and stuff like that. So I would argue here that state is effectively flattened out entirely if you can do things right. maybe that's the right way to say it. And I don't know if that's fair. That's why this is only a hypothesis and not a theorem, or like I'm not saying QED this is true. But I think my experience is kind of hinting to me that I think this is true, and we'll see. I'm legitimately intrigued if anyone thinks this is absolutely wrong. So if it is, make sure you reach out to me on Twitter. But I think the verdict for declarative programming is worst case scenario, you're in an n squared complexity, which is still pretty bad. Like, and things can get bad, but it's at least better than our n cubed we can get to with imperative programming. So that's what kind of where we get to the DeRose hypothesis. Given a UI component as defined by some set of dynamic properties and states and events, and given the number of dynamic properties, states, and events are not trivial, then it follows that a declarative implementation will be at least an order of magnitude less complex than an imperative implementation. So that's my hypothesis. I don't know if I mathematically proved that or not. Alex, you'll have to tell me, or anyone, just tell me on Twitter. And like Nicole said, catch me on Twitch. And also, I work for Nrwl, and we do awesome stuff. So make sure you check out nx.dev if you're at all interested in mono repos, or if you just like really cool tools. And make sure you check out NX Cloud, which Nicole's leading. This cool product we're working on to like do a distributed cache for your NX mono repos. So that's it for me.
Awesome.
Hey.
That was fantastic,
Yeah, that was
Zach.
Very cool.
Hey.
really awesome.
That was really great. I like all the I definitely like the braiding lesson. that was pretty awesome. But it made me kind of think back to like when I started programming, and I think everybody sort of has a moment like this where they start to see that like programming is kind of like, you can kind of think of everything in your life as like programming, like breaking down, like waking up and like getting a cup of coffee in the morning, and like, you know, having all these like pieces that you have to like break down into individual like I don't know, just individual movements or like factors. And yeah, that was like a big breakthrough for me when I was like starting programming. So I really like that you integrated that.
Yeah, thanks. Yeah, in my first job as a engineer, I guess, I actually worked with the president of the company. Was just like, he was one of those guys that was extremely talented. I felt like he could like manage like 8 balls or 8 or 9 balls in the air, like when he's coding. I could see him doing this. I thought like, that's where I need to go to. Like, if I want to be successful in here, I just couldn't do it. So that was a huge lesson for me too, is just like, well, some people are just more talented in a certain way. That doesn't mean you can't be like as good of an engineer as them. You just got to figure out, you know, what works for you, and figure out the things you can change, the things you can control. So.
Yeah, I think it definitely has something to do with how much you can keep in your brain at one time.
Mm-hmm. Yeah.
Some people seem to be able to keep a little bit more.
Yeah. But for those of us that can't keep as much, that's why we got to find out these like patterns or designs that just give us some sort of advantage, or like give your team some sort of advantage. Mm-hmm. That's probably the better way to think of that.
So where would you recommend people who like they see, like you're talking like, oh, I really want to try, you know, more declarative programming working with RxJS. Where would you recommend that they start?
So if you're interested in declarative programming in general, like, and you know, just as a thing, like the guy I mentioned, the guy who created Clojure. Clojure is a great way of kind of learning that. It's like really weird syntax. I've tried to get into a little bit, but that's going to like really drill that into your brain. But I think RxJS is this great library for kind of understanding that. And to be clear, like I think I maybe skipped this where I meant to talk about it, but you can absolutely do imperative programming still with RxJS. And I think like a lot of times you see, okay, I'm going to, like in Angular world, we have the HTTP client. I see so often we're subscribing to that just so we can set another property.
The component.
Yeah, so we could just go back to imperative. and like that's kind of like the change detection in Angular is built around being imperative. Like it's so you can just be imperative, and like that problem I was talking about in Java Swing, where you like don't know how to update stuff. Like Angular just takes care of all that for you, which is amazing. But it kind of steers you off course from this other really cool paradigm, which could really help you if you can kind of get your mind around it. So yeah, there's a lot of cool resources out there for RxJS. I'd love to get some sort of like a course out there at some point, but I've got a whole series of like stack blitzes about that, and it's such a hard thing to try to teach, though. It's like you got to get the mindset. I think if you can get the mindset that I tried to show in this presentation, that's like most of the battle there. Everything after that is kind of learning the technical pieces of how do I really define this pipe. And ArcsJS is like, it's very difficult in that matter. Like I've had so many times, I think even now going through ArcsJS, like one operator does things a little bit differently than I thought, or like understanding, hot versus cold observables. That was the last presentation I gave at Angular Seattle. That was like a huge, like, what moment for me to understand like the difference between those things, because it's not something you would assume if you didn't know about it beforehand. So I think the best thing you could do is just try to do it. Try to see, am I really, like, just being introspective about your code. Am I really keeping each of my threads like as uncomplected as possible? And be honest with yourself. Like, if you're not, try to figure out how you could have done it better, because that's kind of where things go. If you're in Angular, always use the async pipe. Try to never subscribe. And yeah, that's maybe the lesson to go with. So yeah.
Cool. Thank you so much, Zach. That was awesome.
Yeah, of course. Yeah, thanks for the opportunity too, Nicole. This was really fun.
Oh yeah,
So.
We always love having you on. Cool. So should we jump into the next presentation with Alex?
Yeah.
All right.
You ready?
Let me share my screen. Yeah, that was a really great presentation, Zach. So it kind of, I'm happy that you went first, because you sort of basically my presentation that can be easily woven into your talk about the ArcGIS and stuff like that. It's really nice, because I kind of agree on some of the things that reactive or declarative is really helping in a lot of cases. Even though Angular has those little friction points between the imperative and reactive, and with the Nrwl component store, for example, this is one of the. It's not an objective, but it actually helps. I feel like it helps solve some of these friction points, and we'll talk about them today, since I have a good chunk of time today. All right, so I'll start with the indirect component. All right, so just a quick slide about myself. Although Nicole did a fantastic introduction already, I work at Google on Firebase console itself. We write with Angular, we use Nrwl, we love it, and all that. I also part of the Nrwl team. Organize Angular Toronto.
Here's a result from search.
Oh, yeah, my phone reacted to Google. All right. Yeah, so organize Angular Toronto, and I'm part of the in-depth.dev, great team of people, community. It's like all volunteers, articles, and many other discussions. And now it's a podcast also, and Santosh talks with Tech Talks with Santosh. So it's a nice community. So everybody is welcome as well. All right. So now steering a little bit back, Nrwl component store. What is it? What is it? Well, it's a state management library, right? And for those of you who are familiar, like already with Nrwl, like hold on. A state management library doesn't Nrwl already have a state management library? Well, it does. It has a global state management library, and there were some things that it wasn't solving quite well. So I think component store can fill in those gaps and can live together with the global store by itself with other global state management libraries like Akita or maybe even JSX. So the tasks and objectives of this library is a little bit different. But before we go into specific details, let's try to say this is state management library, right? So it's state and it manages it. Let's basically break apart this into things. And so what is state? Right? What is it? What is it trying to manage? So we have a clear understanding, but at least have some understanding about what I'm talking about today. So what is state? Well, there are, again, many ways to split it up. The way I see it and the way I kind of saw other people already, put the state thing together is there are a few states. There's a server state, right? Server backend state. That's a source of truth, basically, right? This actually has, all the entire state. It saves it and it has all the data about the user and everything else. And then there's a web app side, right? And then on the web app side, we're basically trying to get some snapshots of that data, right? So we have like persistent state on the web app. We have URL state, we have client state, we have local UI state, we have a bunch of other states, but this is the ones that I'll cover today in a very brief introductory matter. All right, so let's look at those 4. So persistent state, and I'll be showing on Firebase console. I work with it. I work on this authentication as well. So it'll be probably more, something you can, feel almost. All right. So what is the persistent state? Well, this is the snapshots of state that we grab from the backend, right? This is our API responses. We request things, we get those, data back. So that data is a persistent state. And when we change it on the UI as well, we then persist it to the backends, again, through some of the API calls. So this is a persistent state. That's what I mean when I say that. So what's the URL state? This one's kind of easy. This is the URL itself, right? So sometimes it also people put like router state. So router state can have a little bit more things attached to it, but basically URL state is good enough. It's the state of your URL. And then there is a client state. So the client state, it stays only on the client. It doesn't go anywhere. It's not persisted. For example, which tab is open right now? And right now I have 4 tabs and sign-in method tab is open. So it's not persisting when server backend doesn't care what you're on. URL does, but we'll talk in a second about this. So this is basically the client state. It stays on the web app itself. And then there is also like local UI state. So for example, this enable button, right? Right now, as a button, as a component, it has enabled, it's like on or off. By itself, that component doesn't care where it is, because you can see there's another enable button right underneath it, and it's just a duplicated one. So within that component, enable is just a toggle. Is it on or off? Yes, it's attached to the persistent state, right? So getting back, is it this email password provider? Is it enabled or not, right? So it is being attached to the persistent state, but within that component, it doesn't care. It takes the input of, am I on or off, right? And if you click me, I'll change that state. So this is like a local UI state. And one of the hardest job of the web app developer is actually trying to synchronize all of those states, right? How we persist it, how we get it back. There's always a delay. There's a CP request going back and forth. How do we, user clicked on different tab. How do we do? What do we do? Do we change internally? We should probably update the URL state, which would cause another persistent state request and all of that. So all of that synchronization is one of the most complex things. And this is why we have those state management libraries to help us organize some of it, make it more predictable, and make it more consistent. All right. So this is the state part. So how is component store managing it? Well, as any state, it needs to do a few things. It needs to be able to read some state, it needs to be able to write some state, and it should be able to create some of the side effects. If you're familiar with Nrwl store itself, there are corresponding things for it. Like for reading, Nrwl store has a create selector, right? So it selects from state. For writing, there's a create reducer. Basically, it reduces the state, updates the just internal state. And for side effects, it has a create effect. And again, we won't go into details about it. This is just, if you know it, it's great. If you don't know, that's fine as well. So Nrwl component store has corresponding things as well. So for example, read, we can select things from it. This way we would read the data. There's a write for updating the data, And there is also an effect for side effects. So basically, any of the state management libraries, they deal with these three things, and they're trying to organize some of them. Component store has a few more, but we won't touch on those today. And especially since some of them should be, only used in specific places. They're just like almost helpers. All right, so we have those reads, writes, and side effects. Let's look how we would write our typical component store. And before we actually go in there, something I want to touch on is component store itself. The scope of it is different than a global store. So what it's trying to manage is a more localized state. So something that's closer to the actual components. And the way it's trying to, the main objective actually, when I was writing the design doc for it, and like, hey, the main objective is I want to replace those services, with the subject. So basically, service that has a cache, and usually behavior subject cache, right? So because those are basically trying to store some of the state. So I want to replace those. And why those are not, those are still okay, right? Those are still okay implementations, but I'm trying to make it better and simpler to use that, trying to easier to organize this. So the component stores are basically should be, services with the behavior subject replacements. At the same time, they're not just services, they're still like a push-based services. And again, we'll see it in a second, versus like a pull ones where you request things directly. Okay, so how would you write the component store? Before we would have an interface that would tell us which piece of state it's responsible for. So this component store, for example, would contain the author state. An author state would have like author's ID, name, books IDs that this author written, and the status of the of API, how we're getting this data. So this would be its state. This is the state that author store would own, and only it would own it. Nothing else, nothing on the bottom. We're not keeping the state anywhere, not duplicating. Okay, so then the way you would write your own component store is you would extend the component store and provide the state that it is trying to manage. We extending the component store because component store provides us those methods like select, update, and effect, and others. Those are basically just the tools themselves. This is the mechanisms. Here in this author store, we are wrapping it up with some business logic. So it would know how exactly and what to do with those tools that component store provides. And one of the first things we can do is we can initialize the state. We can do it right there in the constructor, or we can do it later lazily, which I won't cover today, but there are other ways you can do it later on as well. So it's not like you have to have your state from the get-go. You can basically have it a little bit later. Okay, so we'll start with this select, right? So this is how you would read it. And again, select is a method that is provided by the component store itself, and it with this method you pass basically a callback. You tell, okay, you give me a state, and I want to extract the name out of it. So you say how exactly you would extract it out. So you remember our state had ID, name, status, and other things. If we want to get the name out, we would do say.name, and it basically now our name with a $sign is an observable of the name. $sign is a typical way, a suffix for observables. So this is now can be used in the components and can be written. Okay, now let's take a look how we would use this component store in a component, for example, for this name. First of all, we'll see that we use a providers. It's a component providers, and we pass in the author store in there. What we do there is we attach this service to the life cycle of this component itself, right? So that means that when we destroy this component, the store would be destroyed. Okay, so that's why we push it into the providers there. Okay, and now And also for each author component, should we have multiple of them, each one will have their individual author store. It's not shared, it's individual per that component. And then we just inject it in the constructor the typical way we inject services, which is like, for example, private read-only author store. Okay, so this is how we do it. By the way, okay, yeah, here's the name. So this is how we get the name out of the store, right? Out of this component store. So we do author star.name, and then we basically extract it. So what it means is that if anything in the store changes this name, we'll get this name right away. And we will probably use this name with the async pipe in the template, and the whole thing becomes reactive. So what we're doing here is like a push-based approach, push-based almost service. We don't care, author component doesn't care what changes the name. All it cares is that the name gets changed and it reacts to this. And by pushing all this logic into the author store, into the service, we are really, really simplifying our components. They can be really, really small, and they can be, very easy to read. And they basically act almost like those functions that take some inputs and provide some outputs, and they're very easy to, to use, to read, and to understand. Versus, those components that are just wall of text, lines, like hundreds and hundreds of lines of code. Anyhow, so this is how we would select a name. Okay, so we can read. How would we write to this component store? Well, the way we would write it is with the updater. So for example, here we would have an update status. An update status is an updater. And what we call is this updater, and then we tell it how we want to adjust the state. For example, we have a previous state, which is the author state here, and I have a new status that we're passing. So we're updating the status. And we say, okay, once you have those two, the way you would manipulate it, then you would spread the previous state and you would push the new status in updating that property only. So now this update status is actually a function. And I could call that function, if you can see down there below where it's highlighted, this update status for loading. What it would do, it would push this loading into the state, right? So now you basically override the state and say, okay, my new status is loading. And if there is something that's listening for that status somewhere in a component, it would know that, hey, yeah, that one actually changed, because it would select that loading. They would select the status and it would automatically get updated. And you see even further below, there's update status to loaded. So that's when, when it's complete, we know the status is complete. So this is how you would use it. You would use it kind of imperatively almost. You can pass update status, you can pass observable to it as well, which I won't cover it, but you can almost call them imperatively, which is really awesome, especially if you're trying to attach them to those, click handlers in the templates, which just call, methods in your components, because then you can just pass that value imperatively into your component store, and that reduces that friction where you would need to subscribe somewhere just to you can pass things to. All right, so this is how you would do the updater. So we can read, we can write, and the last thing we'll cover in this one is an effect itself. So how we do side effects, and what are those at all? Side effects is like, calling your HTTP service or having some timers or anything really that you want to do in asynchronous manner. So this is what the effects are. And the effects are really actually one of the most powerful things in the NGRX global state management. Very, very easy to miss. For example, you have a service that calls the HTTP on click, right, and updates something. If you just have in your method there wired up just to call the HTTP method, and then somebody clicks multiple times, as Zach was showing today, you click multiple times the same thing, you are basically creating every time the new request, and those observables have no way to interact with each other. and you could basically end up with those race conditions. The effects allow you to actually orchestrate them and bring a little bit of harmony into that, and let you actually choose how would you want to do what you want to do if your previous request is still busy, for example. Do you want to drop the new value? Do you want to wait for new value? Do you want to set it in parallel? Whatever you want to do. So all of those is orchestration is what it makes effect so powerful. All right, so let's get to this get author effect. As you can see here, I'm passing it IDs of observable. And again, this, just like an updater or select, within those helper methods like effect, I'm passing basically a recipe saying how to do things, right? I'm not saying what to do, I'm not saying how to do things, right? So in this effect, here's the IDs array, observable, sorry. IDs observable. And when I say, okay, then I pipe it. And I filter it, for example, making sure this, there's something to work with. It's not null, for example, because I could pass undefined anyway. Then I would tap and I would call my updater saying, okay, let me just go by it. All right. Then I will tap and say, updater, set this to load it. All right. So now I'm loading something. And then I'm having this switch map. And switch map is this exactly the flattening operator that allows me to orchestrate my race conditions. So there'll be no race conditions, right? So for example, this one, if there's a new ID coming in, it would cancel the previous request and start the new one instead. So what this one does is calls my author service that actually does the HTTP call and get the author. And then once I have the result, I can tap the result into the next one, which would be set author. And set author is an updater, just I didn't show it. It's just another updater. So it just sets this author into the state management. And then update status we see already to load it. On the error, for example, I would update status to error, right? In this way, my component can show some error if it wants to. And one other thing is I'm catching the error. So just my effect is not collapsed. Should there be an error? All right, within this switch map. So this is how I would, how I orchestrate my effect. But how would I use this effect? How would I use this effect? So here's my input, for example. And input is ID, right? I'm setting the ID. For example, this author component accepts the ID of the author, and then it wants to load it. So this setting ID, it calls the author store get author and passes this author ID. One thing I want to draw attention to is get author, I'm passing a single ID, right? I'm passing a string to it, to the get author. But you can see in our effect, the IDs were actually an observable. How come? Well, what happens underneath it is that every time I call get author with the value, it's actually being pushed into a single observable stream. And then my effect with the get author in the component store is my prescription how I handle all of these values that are getting pushed into this. So this is like a little bit of magic, but again, it kind of removes this friction, right, with the imperative and declarative or imperative reactive programming. IDs inputs in Angular, unfortunately, are not reactive, right? I'm not work with the observable there unless I have my own, I have to create my own subject and push values into that. But component store makes it a lot easier to work with. And also, at the same time, again, this removes all this business logic out of the component, out of the way. It's very easy to read this component. All right, so this is now we have the read, the write, and the effect. Hopefully you're getting some idea how it could be used. So and how it's actually trying to manage the component, component state. All right. So how is it different from the global store that we had before? Well, it's actually the responsibilities are quite different, right? So the global store is basically trying to organize everything app-wide, right? So it's like trying to have an event that can, different parts of the app can react to it and all that stuff. This one, you cannot really do this because you have to call this methods or effects or updaters explicitly. But there are obviously more other different differences between those two. So for example, in the Nrx global store, we had those create selectors, create reducers, create effects, and all of those are all in a separate files. This is done because the scale of it is completely different. We're trying to organize almost by responsibilities. There are things that are selecting, and they don't care about anything else. There are things that are reducing, and they could be reacting to multiple those actions that are flying around. There are multiple effects that are organized in different things. The scale of that is quite bigger, and they're all separate files for that purpose, right? They're each taking their own responsibility. While in the component store, it's actually in the same file. So the selectors and updaters and effects, those prescriptions, those recipes, those how we deal with it should be in a single file. And that means that they would be kind of smaller, right? Because, well, trying not to grow this one a lot as well. There are obviously other ways to deal with some of the selectors, could be additional ones, but I'm not going to cover that today. There's also difference how they hold the state. For example, in the Nrx global state, while it's one single global object, it's a single global state. While in the Nrx component store, it's a different story, right? Because we have so many different those services that hold that state. And in the Nrx store, the create reducer is still responsible for that single slice of state, right? And so should be the component stores. Even though there could be multiple different independent states, they should be independent. They shouldn't be interacting with each other in terms of writing other data, rewriting other data. They should really own their piece of state, and should they be consumed by other component state stores, because there's actually could be multiple of them, they should be consuming them through like selectors and things like that. Okay, so this is the other difference. And the last difference that I want to touch on today is Nrx store lives through lifetime application. So that state is always there, right? Your component, you move, navigate somewhere else, the state is still there. You can select it, you can clear it, but you have to clear it yourself. Nrx component store, by design, is attached to the component lifecycle. So that means if the component which it's attached to gets destroyed, all the state of it is gone. And this is quite on purpose, obviously. Okay, so this is the differences between those two things. Now, where would you use a component store? We'll cover a few things today. We'll take a look at the module state, some of the shared a common component state, complex independent component state, a reactive local UI state, and lastly, there's a provided in root as well. We'll look at some of them in details, and some we'll just quickly talk about. Okay, let's talk about the module state. What do you mean by module state? It's not ng modules. It's not any other modules. It's not JavaScript modules. It's completely different module state. Module state we call something that's kind of self-contained but still fairly large, but still self-contained. It's like a module. So, for example, in the Firebase console example, we have like different views. We have like what we can do. For example, we can have authentication right in Firebase. So your projects can have like all those either third party or just email password authentication. We can have database, which again could be like a Firestore, real-time database, all those different basically items, and storage as well, and further on. So those are all what we call the modules. They are completely independent. Authentication has authentication state does little or nothing to do with the database or storage. Yes, some of the state trickles down from the global state. For example, the project I'm on right now, which is like Fireless here, for example. But then then within the module, nothing really goes outside of it. So that's what we call modules. It's almost like a single large page. Let's look at this authentication module, for example. So here is a list of sign-in providers that you can tie your authentication to. For example, you can use, just email password with your Firebase projects. This is one of the providers. Or you can use, phone providers. If you don't want people to bother with the emails or whatever, or even third-party authentication, you can use your phone authentication. Or there is like third-party auth, like Google authentication or Twitter authentication. So those are all different providers, and clicking on each will basically show this pop-up. All right, so those are providers. They obviously can't be by itself. So those are provider components. They still have to live somewhere. Well, and that somewhere is they live in this sign-in providers, which is identity providers component. So we have now our provider components. They live inside identity providers component. But it's not, it's not the end of it. There's also, right now we are, for example, at the sign-in method tab, which is a providers tab. But there is also users, there's templates, there are other stuff on top of it. So the entire thing is what we would call, authentication page component that contains all of these things. So for example, here's our users tab and templates tab and this auth index page that basically governs all of it. So what's interesting is that the APIs that we call for this authentication thing, they give us back a lot of like configs, and that data is basically shared through all of these tabs and trickles down to all different places. So what we ended up doing is we're having this auth config store, which is tied to this auth index page lifecycle. So basically, auth index page owns that state, and then it just gives all of the pieces that are needed through those selectors to different components, and they each inject this auth config store and take whatever they need. They have preset selectors, and they just say, okay, if the users from the config changed, the user state will react and redraw and re-render and show new information. If provider was enabled, disabled, something else. If there's a quota underneath, it uses something else as well. So basically, we now have an index page that owns a piece of state that is shared throughout this component tree. And what's interesting, if we go to the database, this whole state just blows up. We don't care about this anymore. What's interesting as well is, for example, auth index page here, it has one of the stores, but then actually has two stores, which is a separate store that we have at the same level, like onboarding store. It's only needed for the authentication index page, for example. It's just a state of, hey, was the user, like, did the user ever came to our authentication before or not? So we can show a different welcome page, maybe some video tutorials and stuff like that. But what I wanted to show here is that there could be multiple stores even at the same level, and they could be used throughout this component tree. What's interesting and very important actually is that those stores contain data that's completely independent and doesn't interact with each other. Otherwise, you'll get basically what I was calling always like a service soup, where different services inject different services, and now you lose track of where the state is. Okay, so this was a module state. The second one is, I put the star there because this was actually one of the first examples how component store was born. Component store was born within Firebase and then basically adjusted into this Nrx proposal. And the typical problem that we have there is something that actually so many people ask me about, how to do these things with the global state, and it was hard. Let me show what exactly what I mean. So say we have like app component, and we have a few pages on it, right? Each page has its own components and it does its own things. For example, page 2 has component A, B. There's other components in page 3. And then yet we have another component that could be quite complex, but it's shared at the same time on the same page. Could be multiple instances of it, or it could be different pages. But this is a common component, so it does not inject any other services. The only way that it interacts with the environment, with its parent component, basically, is through inputs and outputs, both of those. So it could be placed anywhere in the application. All it knows is, it communicates with inputs and outputs to the parent component. But that component could have a complex state, even maybe, calling some of the HTTP to do some validation or things like that. But it's completely self-included. All the inputs that it needs, it gets in there. So what we ended up having is this component store. This was basically the birth of this component store. And it's tied to this common component, and it could be, managing each individual common component state. Frequently, there could be, on a single page, there could be multiple. For example, we had author component examples. Say we have multiple authors at the page at the same time. Each one of them can take the IDs in, and that's all they care about, is because they can now talk to the services, get the data that they need, and maybe if somebody saves the author data, they can still persist it to the backend. So this was one of the really important case that was quite hard to do with the global state management, because the way to do it was to do it by index or something like that, which was like, hey, now you're getting all of this data indexed into the global state, and it will never be used anywhere in the application outside of this component state. So that was a little bit like that feeling where it's like, I don't want to really do this, but I don't have any other options. Yeah, so now we have those options. All right, so complex independent component state is kind of like a module state. It's just a little bit more smaller scale. The idea is basically the same. At some point, you have some state that's shared, that can be shared only downstream and not upstream, self-contained, and you can have the component store at that level. Kind of like a module in a smaller scale. And what's interesting is that you can have those component stores, in theory, depending how big your application is, at different levels of the component tree, right? As long as that component store is responsible for the state that does not get out of that, node of that component state tree. All right, so this was independent component state complex. So reactive local UI state. There's a lot of talks about zoneless and all that stuff. Do we need zone? Do we not need zone? We cannot patch promises in the latest version of JavaScript and all that stuff. So there probably would be we're basically slowly starting to move into the zoneless, or at least have to start thinking about it. So right now, if you have a zone and you have even the same enable button, you click on the button and it's basically a property, right? So you click on it and you just say, oh, enable, just flip that bit, and it will be like it was true, now it's false, right? And that's it. And then component, and then Angular change detection runs. It's like, oh, it's a new value. I know. Okay, let me just put it into the re-render it. However, with the zoneless, it won't work because there's no zone to run in, right? So there are other means to do it, even with the NGRX like push or let pipes that are in a separate package. So basically, we need now to tell when we need to do it. And one of the ways to do it is to use this reactive style. And instead of just like a sync pipe, there would be something like a push pipe or NGRX push pipe. So the reactive local state of the component is also a good use case for the component store. Lastly, I said a number of times that the component store is typically tied to a particular component. in this component tree. However, there are some use cases where it could still be, good use of provided in root. However, if you're trying to do it that way, I would strongly reconsider it and see if you're getting into the a global state management territory, and this is maybe where you would need to use something like the Nrwl store by itself. But it's also an option. I mean, I can't say no, it would work, but you have to be very careful with this, and that's why there's an exclamation mark there. All right, so this is the major use cases. I would also like to thank this group of people. Kevin Yelko is my teammate in Firebase. He actually the one who started working on this component store idea last year, and basically created a version inside Firebase, that basically a lot of people liked, and that's how we decided to, push it upstream. Then also Brandon Roberts and Tim DeShriver, those are my Nrwl teammates who spend also countless hours, reviewing the code, getting the feedback, all the discussions, this and that, because it evolved quite a lot from the original implementation. And also Nicholas Jameson, the RxJS guru, is from Reactive's core team, is just fantastic. And a lot of great feedback, a lot of great advice I got from him. If I want to bounce off some ideas, he's always there to help and provided huge input for this Nrwl component. So definitely, follow these old guys. Kevin's not on Twitter actually, but yeah, follow and they are fantastic and they provide fantastic content as well. Both Tim, Brandon, and Nicholas have their blogs as well, so definitely check those out. All right, so this would be the end of the presentation. We are mostly finished with the code, so you can always go and download the nightly version of it. So there's nightly builds. I should probably have a link for it, but you can find it on the site Nrwl.io. There's a recipe nightly builds. You can find those, how to download the component store. There would be some little changes within the component store, but the whole thing is fairly stable at the moment. And we would be releasing it also fairly soon with the Nrwl version 10 release. Right now, I'm working hard on the docs, so it's not only so you have at least some guidance how to use it, and you can always rewatch this video as well if you want to. Anyhow, this would be the end of the presentation for me. Thank you so much for joining.
That was awesome.
Yeah, that was so
cool.
All right. Hopefully,
we were just talking about how useful that is, and I'm so glad that like in the beginning when you were explaining it, I was like, oh wow, I wonder where sort of what problems arose that prompted the development of this. And I'm so glad that you went into the history of where you were using it in Firebase.
I'm a big proponent to. Oh, sorry.
Oh, go ahead.
Yeah, I'm a big proponent to have small components. I want to treat my components basically just like a simple functions that take some input and have a template and basically render that and put those inputs into the template. And then when the user interacts with the template, what they do is basically have those outputs either through the service or through the dispatched actions or calling those updaters or effects within the component store. But basically to have a component that have any of the business logic almost stripped off. That way, testing those components is like a breeze. You just give it inputs, validate the template, and you're good. And then you can test all of your business logic without setting up the test beds and fake asyncs and all that stuff, right? You can just, it's a class now, right? It's a class that you can just easily test all your business logic with. And it's just such a pleasure to do this. I know not a lot of people do unit testing, although hopefully the number grows. I love unit testing. It just gives me so much confidence, especially in the project that's supposed to live for a long time, like Firebase Console, right?
Yeah.
or others. But yeah, how do you feel? How do you treat your components?
Yeah, I like that idea a lot. I know that the concepts that you talked about with component store, once it clicked for me what the use case for it is, like I know exactly like 3 places in the app that I maintain that it would simplify a lot of stuff that we do, because we're having to kind of like what you're saying, you have to like manage it based on like indexes if you have multiple, and and you have to kind of reconcile everything. That's always expensive and complexity, but this would simplify that a lot.
Yeah, that's so true.
Is it compatible with like Redux DevTools?
So it does not have the Redux DevTools. One thing that I forgot to mention, the entire component store, it's over 200 lines of code, plus a custom operator, that's another 50 lines of code. So it's 2 files, which one is just a custom operator, which you only need to use until you get into more complex things, and basically 250 lines of code. So it is almost designed to be a drop-in replacement for those services with subjects where you're trying to organize, orchestrate everything. Because effects is one of those things that even in the push-based services, effects is one of that thing that frequently gets dropped, and all those race conditions, they start to result in the issues that are coming from customers, because you never test for race conditions. I never do. I never test for race conditions, right? I don't say, oh, let me have a test that clicks the mouse twice and I delay response from the first one and the second one arrives before the first one. I can never do that, and I don't think anybody does it. But yeah, this is just those things. Here you are basically when writing effects, either in direct effects or within the component store, you are almost forced to think about it. Oh, how would I flatten this, right? How would I flatten? What would it be? Would it be merge map? Would it be switch map? Would it be concat map or exhaust map? Like that's what I kind of also like about this.
Yeah, absolutely.
How
What do
about?
you think, Zach?
Oh yeah, go ahead, Zach.
No, I was just thinking when you were talking about switch map versus concat exhaust.
Yeah.
That's like the story of my life. so interestingly, I think the I was thinking back to the question you had posed to me, Brendan, about like a really good way of learning those things, and learning it well. Unit tests, like we had talked about. If you can use like the test scheduler and like use the marble diagram exposed by the test scheduler to kind of say, you can kind of get those temporal arrays where you can just set it to anything you want and say, well, let me make sure this is doing what I really think it is. I usually hate doing unit tests. I think they're kind of pointless, because I think I don't know. Integration just throws everything out the window. I think end-to-end tests is the way to go. But unit tests are extremely good at making sure you coded what you think you coded. And for RxJS stuff, I think that's really important. So like NGRX effects and probably like the component store effects, I think that would be a really good fit. So, because you're never really sure what switch map does. No, you can be. It just takes a lot. So.
Yeah, it's
Alex, you mentioned push pipe.
yeah.
What do you mean with that?
So you know how there's a sync pipe, right? That basically, a sync pipe, just for those who are also listening, and it's a way to subscribe to observables and push those values in the templates. But what fewer people know about it is that it also marks that component for check, right? So this is for change detection, so that for the next tick, when the tick runs, this component would be, asked for check, especially with the combination with change detection on push, which, basically says don't check me unless I ask for it or my inputs change, right? It basically some of the performance optimizations. So the thing that triggers or schedules the stick is the zone. So ng zone schedules the stick. However, if there's no zone, there's nothing that can schedule this stick, right? So this push pipe, nrx push pipe, or there's other libraries as well. What they do is they, instead of just saying mark for check, they can say, okay, detect changes specifically. Or there's a way also to coalesce this, so basically organize all of those detect changes, all of the components that want to do it, and later run it when it's ready, right? So this is very similar to like async pipe, but it's for the zoneless environments, so they could help where there's no zone to schedule all of those change detection runs. But from the user perspective, it could be just almost like a drop-in replacement for the async pipe. Now that is still something that nrx team is working on, and there's another library that's also working on this. It would be in the nrx/component package. So those where this nrx push pipe would be, and there's also nrx let directive as well.
Interesting. Really
Yeah.
cool.
Zoneless is an interesting topic on itself. I mean, people have been discussing zoneless like for forever, but I think now we're start getting a little bit more serious about this, right? Especially because there's a limitation in zone that just there's no way you can overcome those native asyncs awaits. Although, if you are strictly in observables and you don't use any of the async awaits, you should be good. You shouldn't be too worried about this. But then there's always like one of those libraries that you use that would have some promises inside, and those won't be patched. And now you're like scratching your head why this thing is not working, and then you have to debug the library, third-party library. So that becomes a little bit problematic. Yeah.
Yeah. Cool. Well, thank you so much for that talk. It was really cool. I learned a lot, and I can't wait to try it out. Yeah. So I think the next thing is we're just going to be hanging out on Rambly if anybody wants to join. And did we throw the link up somewhere?
I will in a second.
Okay. Cool.
Yeah. So there's the link in the chat there. You can just copy and paste that into your browser and come join us and walk around in Rambly.
Awesome. Thank you so much, Alex and Zach. We really enjoyed having you.
Yeah, this was a blast.
Thank you for having us.
Thanks, great talks.
Thank you.
Have a good
See
one,
you all
everyone.
next time.
See ya.